Alright guys, so we want to prove this half angle. We must have seen this in some of our textbooks, or you notice the lecturers actually made use of this formula. So how do we solve it? How do we prove that the half angle of a sine is equal to the square root of 1 minus cos s over 2? So let's quickly get it solved. We are going to be proving for sine, cos, and I'll probably show you the one for tan. Alright, so recall from this trigonometry identity. You can remember that cos A plus or minus of B is equal to cos A cos B, right, minus plus sine A sine B. I'm very sure you must have seen this before. Now suppose you now have cos x plus x, right? And that will be cos x cos s minus, because for cos identity, when you have plus here, you have minus here. Alright, so I'll have sine x sine x, and cos s plus s is the same thing as writing cos 2s. Okay, very, very fine. So here cos s times cos s, that is cos square x, because they are the same thing, minus what? Sine square x. This is another identity. Cos 2s is equal to cos square s minus sine square s. Some of you should know how to get this one. Now recall from our very first trig identity, from cos square x plus sine square x. Sine square x, is equals to 1, which means that cos square x can be 1 minus sine square x. Just collect like terms. So in that case, instead of writing cos square s here, I can decide to write minus 1 minus sine square s. So my cos 2s will still be 1 minus sine square x, which is representing cos square s, minus sine square x, and in that way that will be 2x is equal to 1 minus 2 sine square x. Okay, because I have this one here and I have this one here. Alright, so that is where we'll continue from. Alright, so here from here now, from this place, we now have cos 2s. Cos 2s is equal to 1 minus 2 sine square x. Sine square x. Okay, now I can as well say that this is 2 sine square x. 2 sine square x is equal to 1 minus cos 2s. I just collected like times. Okay, so I divide both sides by these two. I divide both sides by this particular 2 here. So I'll be left with sine square x is equal to 1 minus cos 2x. I have to square both sides, so I have sine x, in other words, is equal to the square root. Don't forget I have over 2 here. 1 minus cos 2x over 2. What does this simply implies? If this is x, this is times 2 of what is here. So we can now say that this one here is the half of this. Therefore, I can now say that sine at an half angle is equal to 1 minus cos s over 2. This identity is very important, especially when you get to calculus. You will need it a lot. When you get to your trigonometric substitution, you will be needing this to apply in your calculus, probably in your integration and all of that. So now let's prove for cos. Just from the place we started from, the particular identity. You know, I said cos 2x is sine square x minus, is cos square x minus sine square x, and I record cos square s plus sine square s is equals to 1. So when we want to get for in terms of cos, we can also say that from that formula that that my sine x square x sine square x is equal to 1 minus cos square x. I actually got this from my sine square s plus cos square s is equals to 1. So I just collected like terms. Okay, same thing goes to this one. So instead of writing sine square s in this formula, I'll just write cos 2s is equal to cos square x minus this minus here minus 1 minus cos square x, which is representing this sine square x as regards to this place. Okay, so I'll have cos 2x is equal to cos square x minus 1 plus cos 2x. Alright, then I can collect my like terms. This and this will be plus. So I have cos 2x is equal to 2 cos square x minus 1. So let me collect my like terms. I can as well write this as 2 cos square x is equal to, if I bring this minus 1 to the other side, I'll have cos 2x plus 1. So divide both sides by 2, I will have cos square x is equals to, can actually write it as 1 plus cos 2s, since they are just multiplying themselves, since the relationship is addition, so I can just put it that way, over 2. Can you see that now? So find the square root of both sides. That will be cos s is equal to the square root of 1 plus cos 2x over 2, which means that whatever that is here is half of this, because this one is twice this one. So that means my cos of half angle will be what? Square root of 1 plus cos s over 2. So with this idea, since we know that this is for cos, now we can find for tan. Let's get for tan. Don't forget that tan is sine over cos, right? Tan is sine over cos. Tan is sine over cos. So for tan will then be, for half angle actually, sine, what's sine now? The root of 1 minus cos x over 2 over 1 plus cos x over 2. Then from the law of sort, this can be written as all this 1 minus cos x over 2 over 1 plus cos s over 2, because we both have square root, so you can just come over. So this cancels this one. Therefore, the one for tan actually will also be, let me write it here so we can see it on a straight line. The one for tan will be the half angle for tan will now be the square root of 1 minus cos s over 1 plus cos s. So this is how to do. This is how to prove all the half angles for sine, tan, and cos.